hosting such an awesome event. My name is Tony Chandick. I am the North Central Regional Sales Manager for EPSON Robots. I've been with the company a little less than 3 years. And we're going to talk value today. You guys have talked a lot about collaborative robots today. We are an industrial robot manufacturer, okay? What's the difference? Well, our stuff has to be guarded, like the hard guarding you see out here, or perhaps those area scanners that the pills people have on display up there. So you do need to guard our robots. But if you put a rigid piece of tooling on the end of a collaborative robot, it's not collaborative anymore. You're going to have to guard that too. So a lot of collaborative applications need to be guarded. Our value proposition that we bring to the table is that I can sell you an awesome performing industrial robot that's twice the performance at half the price. Okay, excellent value. That's our value proposition. And what I'll show you a little bit later, we also have a new super easy to use programming environment that a person with no robot programming experience can pick up on and use this really neat Windows-based programming environment called RC Express. So I do have a beta copy with me here today, and we will be looking at that a little bit later. Let's page down here. So let's get into who we are. EPSON, this is our vision statement. EPSON is creating a new connected age of people, things, and information with efficient, compact, and precise technologies. Nice to be a part of that, okay? I'll turn on this little bugger. There we go. Okay, I'm going to give you a little history here. The name EPSON came from the world's first electronic printer. So for the Olympics in 1964 in Tokyo, our engineers, you ever heard of it? That is who we are. We are Seiko EPSON Corporation. And Seiko was tasked with not only keeping the timepieces for the Olympic event, they were also asked to create a printer. So the world's first electronic printer, the world's first dot matrix printer was literally invented. And it was called the electronic printer, the EP, hence the name EPSON. We consider ourselves as a company, the original printer. So just an interesting little bit of trivia there. Skip through a lot of this stuff. We are an $11 billion company. We are into a lot of different areas, but what I want to stress here is that the areas that we are in, we dominate in each space. You're going to be seeing a lot of these coming out. We have a set of glasses that actually have a projector inside of each eyepiece, so you can pull up your email and your phone inside of there. And it also has a high definition camera pointing outwards so that people can send someone out into the field and you can literally from home base see exactly what that person or technician is seeing in the field. So some interesting things happening there. We are part of this commercial business space, and a couple of interesting things from the timepieces from Seiko. We actually invented the world's first digital quartz oscillator, or a timekeeper for digital circuit boards. So we are the world's supplier of those. But we're going to talk about robots today. SCARA robot, the little 4-axis, the little pick-and-place robots you see out there. SCARA stands for Selective Compliance Assembly Robot Arm. And what that means is that there's a little bit of compliance in each of the joints, so that if you're doing a precision pin insertion and you miss your throw by a little bit, as long as there's a tapered hole, when you come to insert, that little bit of compliance will allow the insertion to still occur. So that's the original intention of a SCARA robot. So you have a shoulder, an elbow, and then the vertical quill is what we call it. And we at EPSON literally invented the SCARA robot. So we made the first SCARA robot in 1983. Get to the product line here. Our robots have a unique core mechanical sensing properties to them. So in addition to the encoders that we use for positioning our robots, with the exception of our entry-level units, those don't have this technology, but all of our other robots do. There's a secondary positioning control loop in all of our robots. It's unique to EPSON. It's a unique patented, what's called a gyro servo or gyro sensor. So in addition to the encoders telling us our motion, we are also anticipating servo vibration while the machine is moving. So that's a totally unique patent to us. And when you watch our higher end robots run, you can see it. So our robots are faster, they're more precise as a result, and we can do more with less. Our typical 6-axis robot, if you literally put it on a scale and then take the equivalent FANUC, for example, and just weigh it, we're about 35% less mass goes into our robots. So they're very slender, they're very compact, and they can fit into very tight places. Okay, won a lot of awards recently, excuse me. We were the product of the year at the last assembly show. We intend to be the product of the year at this year's assembly show, but a lot of new neat products which I can review with you today. So our SCARA robot product line is divided into 4 types. We'll drill into each of those. I'll make some mention to our 6-axis portfolio. Extremely versatile. This video is playing out there in the demo room, so we'll skip that. But we have a SCARA robot for every application. All of our products are very aggressively priced. The pick and place motion, that's the intended design for our SCARAs. We can also do dispensing, for example, and do glue paths and things like that. There is an algorithm for doing that. But the main intention of this robot is movements just like this. Okay? The entry-level robots we have out there have the controller embedded in them. All of our other robots require a separate controller to be mounted somewhere in a cabinet. Very, very compact little 175 millimeter SCARAs, all the way out to the reach of a full meter. Let's drill into this a little bit more. And SCARA robots are really strictly just spec'd by speed. So whenever you see a 3, for example, 3 is the 3 kilogram. It would be the maximum payload that that robot can handle. And we just go up in price and performance. Show you a little example here. Whenever any of our specification books call out cycle time, we are referring to this pick and place right here. It's a 12-inch pick and place with a 1-inch vertical. So it's up, over, down, up, and then return. So we're going to have a little race here. This is our entry-level robot. This is our mid-range family, and this is our high-end Gold series. Drill down in here. The entry-level robot is capable of about 40 picks per minute. The mid-range is upwards close to 60. And our Gold series is upwards of 80 picks per minute. We are in the process of redesigning our G series. That number is going to become probably about 100 picks per minute sometime middle of next year. So we're continually investing in our products. The mid-range, the L series, was just redesigned, so there's some really nice features included with that. But again, all of our robots are strictly spec'd by payload. So you pick the payload that you need, and then you decide what arm length, what reach that you need. All the arm reaches are priced the same for each family. So for example, the 250, 300, and 350 are all the same price. It just depends on what best suits your application. Okay? We go up to 20 kilograms on these, and all of our products are available in clean room, and most of our products are available in washed out. So we can get literally sealed or protected robots for harsh environments. This is our mid-range product. This is the L. Still an excellent performing robot for the price. The price of these just came down with the new design as much as 20%. So if you think about the entry-level unit shown here, these little guys start at 7,500 complete. The controller is embedded in the base, and it runs on 110 or 220. So just an excellent, excellent solution. We make mention that it's a kind of a slide alternative. If you're using a couple of slides to create a 2-axis or 3-axis pick and place, there's no point in going through all that work. Just buy one of these. SCARAs are truly 4-axis machines, so we think in terms of the X space as well as a rotary fourth angle, so you can pick up a part, rotate it accurately, and place it, things like that. Okay? Just touch on this series here. This is our RS ceiling mounted robot. What makes it unique is that there's infinite degrees of freedom about the elbow and the shoulder, so they can spin 360 degrees about one another. It's extraordinarily fast for large work envelopes. Think about a great big giant conveyor with a bunch of parts coming at this guy. That's really an ideal setting for this. 550 means that it has a full 1100 millimeter work area. 350 has a 700 millimeter work area, but very fast and very unique. We were the first company to come out with a robot like that. Okay, drill in. This is the T6. This entry-level one here is the T3 at $7,500 each. The larger T6, which we also have out there, is only $9,500 complete. So just keep that in mind as you price these out. Again, these are good for about 40 picks per minute. And the reason we're able to do all of this is because we make every single component that goes into them. So this is 100% vertically integrated, made by EPSON solution. We also have new batteryless encoders in all of our new products going forward. They are actually based on really precise mechanical clocks. So they never have to be homed, and you never have to worry about losing an absolute battery in the field and losing all your positions, okay? So that's a nice addition to all of our new products. Okay, drill down into our C series. This here, again, spec by payload. Note how slender and compact these robots are. It's unique to us. We have an inside elbow robot, which I'll touch on really quick. The largest 6-axis that we currently make is a 12-kilogram 6-axis robot, 1,400 millimeter reach. Okay. The VT series is our new entry-level 6-axis robot out there. That is priced at under 14. It's actually $13,900 complete for the entire 6-axis robot, 900 millimeter reach, 6 kilograms. Excellent value. Okay. These are the C series. Again, these are available in both clean room as well as protected or IP67. This is our new C12. We just came out with this earlier this year. It's selling very, very well. I will state, and this is a state of all of planet Earth right now. Robots, bigger ones like this, are extremely long. Application for a medium or really large robot. Keep that in mind. The lead times, like the supply chain going on right now, is crazy. So, all right, this is the N series. This is a unique patent to EPSON. Most robots, well, all robots, either have to be in right-hand mode or left-hand mode, and there's always an elbow facing outward. In the case of this design, we put the elbow on the inside. So instead of having to move around that elbow, you can literally just move straight through space. So it makes the movements very compact. It can retract and get up out of the way, as shown here. And you can do some really interesting things with this. Plus, we have a 1 meter reach on our largest version of this robot. It can reach a full 2 meter work envelope. You could literally have it mounted overhead tending 2 machines. Maybe it's tending this machine while the operators are changing out components or tooling or whatever. So it's a very, very interesting way of laying out a robot. As I mentioned, this is our VT6L. We have a sample of this running out there. This is our entry-level 6-axis. It can do tabletop, ceiling, or wall. In fact, all of our robots can mount tabletop, ceiling, or wall mount. And one thing of note here, if you're doing a machine tending like this, for $2,000 more, so it's $13,900 normal list. For $2,000 more, you can make it field. So if you're reaching into a CNC machine or an oily environment or a dirty environment, you can get a really, really nice machine tending robot that's sealed. The cuff is hollow, so it lends itself to run the air lines or electrical lines through it. We do not route any lines through this robot to save cost, but that also lends it to easily be sealed. Okay, I'm going to just mention this is our existing programming environment. It's not going away. This is a very powerful machine language type programming environment where you teach the points, the key points that you pick and place and things of that nature. And then you have line by line execution of code to tell the robot to go here, move here, turn this on, turn that off, that sort of thing. But what we do have now is a new programming environment called RC Express. And this is the environment. So if I want to create a program, I can select just an empty program, or I could select simple pick and place. Okay. Okay. So I'm going to use the pick and place template. I also created a virtual robot in virtual space here, so you don't necessarily have to be connected to a robot to program our stuff. In fact, you can simulate with our regular programming environment a robot in theoretical space as well. So you're not hardwired to having to have a robot there. So let's go ahead and hop on in here. Now, if I wanted to add some other commands or some tasks, these are all the tasks that are available along the left-hand side here. In this case, because I'm just going to show you a simple pick and place example, this has this little template. So he's assuming, well, I want to turn the motor on. Now I want to move to my home position. Note that there's a little orange box there that says we have some work to do. We can also just delete this if we don't want to do it. But let's hop in here. Here we specify how we want to get to our home position. So jump is typically how we move. We move up, over, and down. This is the name of the position. And we can go in here, and I can literally jog and teach my virtual space. So I've got a little 3D representation of my robot. I'm going to jog and teach. Even though I'm in virtual space, it still makes sure do you want to turn the motors on. So I'm going to jog this guy around a little bit. You can see he's moving through space. And let's just say I've gotten to whatever point that I want to teach. And I literally just click on teach, and I just taught that point. So we can go down to this loop statement. And this loop statement is exactly that. We have it set for infinite. So this program will run through this loop infinitely. But if you have like 10 parts you want to pick or something like that, you can specify how many times you go through this loop. And then we literally just go to the pick selection here. I would go in and jog and teach each of the individual points for the pick, and then I would also teach the points for the place as well. You were asking earlier about, are there more complicated functions available? Yes. So in addition, we have palette wizards. We have the ability to turn on and off a gripper at the correct time. If we're placing down into a routines we can use here. Display on the screen, ask a question, or do something, give them instructions, things of that nature. We can log events. Advanced tab here. So somewhere within this program, if you want to insert an advanced spell command that is not present along the left-hand side, you can still do that. So if you have more complex things that you need to do, you can kind of flip over to our actual, spell programming environment and insert spell commands into the programs. So this is going to be coming out in just a couple of weeks, just in time for the Assembly Tech Show. So if you guys are going to make the trip to Chicago, we will have multiple workstations for you guys to try out the software, okay? All right, I'll make a mention of a couple other things. We do offer a conversion for Allen Bradley, so it's literally an add-on instruction profile for Allen Bradley, similar to if any of you guys have installed intelligent cameras or different things into RS Logics. We have an option where you can literally install essentially the EPSON robot controller into, and then conceivably there would not need to be any program or any code executing in the robot whatsoever. It would all be controlled by the master profile in the Allen Bradley. So just so you know. Skip back here to make a couple more notes here. Like I said, this is our environment. There are abilities to create what we call no-go zones in space. So if there's a tooling or what have you, you have to import all your tooling into this 3D simulator, and you can specify no-go zones or obstruction type zones in your program, which is really nice. The 3D simulator, like I said, is free. All our simulators are free. All of our software is free, so there's no software options to have to worry about. There's a couple interesting options we offer. The vision guide, there's the ability to put the camera right on the nose of the robot, so as we're approaching, for example, you can use that to guide you into position. We can also set up and calibrate just a separate mounted camera like we have out here on the feeder solution we have here today, either or. From our quartz division, we offer a unique force guide option. And this is a sensor that detects torque and flex, push and pull, twist. And you can do some interesting things with it. Because it's closed loop with the robot, we can do precise pin insertion where it'll hunt for that hole. And once it finds its push point, it will push those parts together. All the data that's being generated by this torque sensor is savable. So if you have an application where you want to do a push test or a pull test or a twist torque test or things of that nature, all of the forces here can be sent out of the robot and stored. Okay, and now we'll hop in and we'll talk a little bit about the flex feeding system. Have you guys ever looked at Azaril type feeders before? No? Okay. Well, Azaril is a company in Switzerland that makes these shaker tables, and they're sound-based vibratory tables as an alternative to feeder bowls, for example. So instead of feeding in here, I'll hop it. Here. Okay. So essentially, the purpose of these feeding systems is to go from just bulk like this, get the parts separated from one another, and get them singulated into your process is really the purpose of these. Talk about bowl feeders and now flexible feeders, but the word singulate, that's the key thing. That's the goal of these products. So you think about a feeder bowls are great. They run really fast, but there's a lot of pre-work ahead of time. The tooling doesn't lend itself to easy changeover from one part to the next, where our flexible feeder. So, and our feeders are typically less money than a feeder bowl system. But what's really cool is normally you would need a separate robot software. You would need a separate vision software running in the background somewhere. You have to program the feeder bowl ahead of time, or the table, excuse me. And then you got to coordinate all the communication between all these different devices, telling what to do when. So there's a lot that goes into integrating one of these. In the case of our feeder solution that you'll see in the demo today, we manage everything fully integrated into a single piece of software, and everything's taken care of for you. It's very slick. The biggest thing about it is the smart auto tuning. These vibratory tables are infinitely adjustable, both in frequency as well as amplitude of the vibration that you're using. So when you integrate one of these, you literally have to figure out what's the best frequency and amplitude for your parts. In the case of our software, which you'll see in the demo, we literally self-teach the sequence on its own. It has a little artificial intelligence routine that it steps through, and we place the parts on the tray. It vibrates at a certain frequency, takes a picture, vibrates at a different frequency, takes a picture, and it watches how the parts react to the different vibrations that are being presented to it. It takes a couple minutes to calibrate, which you'll see in the demo today. But once it's done, it's done. And having integrated several of these prior to joining EPSON, the amount of time savings that the programming aspect of our solution really, really saves a lot of work on your end. So make sure you watch the video. All this different stuff is reduced greatly as far as how much work you need to do to get this to work. It's fully integrated into our programming software, like I mentioned. Couple options to remember. We can do 2 feeders up to the same robot with our entry-level style robots. We can do up to 4 feeders with all of our mid-range and higher-end robots. And those can also, we can have 2 robots sharing the same feeder. If that is something you might want to do, we can do that as well. But the auto-tuning is just the built-in AI is really, really slick. You'll see it in the video today. A couple options here. You can specify zones where you would prefer to pick the parts from. So let's say you're bringing in bulk into zone D, and you want to try to encourage the parts to get over to zone C, for example. You can do little tricks inside of the programming software. But really, you'll see in the video today, the calibration routine is very, very slick. A couple things. By default, these little guys are backlights, okay, as you can see in the demo that's out there. You can also specify front lighting if there's a piece of geometry on your part that you can't identify with a backlight. We can do that. Also, you can specify right side up, upside down. So if your application has a right side up, use the vision to teach the system what a right side up part looks like, and then you teach it to what an upside down part looks like. And then there is a little flipping routine that once the right side up parts have been picked, we can try to flip over the upside down ones and pick all of them as well. So there's some slick little things that you can do with these. They're very clever. Part supply. By default, you'll see here, this is what's called a hopper. So that's just a little single axis shaker that shakes the parts out onto the table. And then once they're on the table, then the table will use that sound vibe, spread them apart from one another so that they're all pickable. Some guys also use like a conveyor just to dump parts out onto. That's kind of up to you. But there are outputs on this thing to control the hopper. So at the specified time, let's say I've got only 2 parts left on my table, I can specify that threshold as to when I start to request more bulk from the input supply. Okay? And there are also some, if you have an ESD, anti-static type application, there's anti-stick. There's also anti-rolling platforms available. So if you have a part like a shaft or something that wants to roll around, they literally put raised braille onto the platforms of these so that the parts sit in between those braille dots. And there's a bunch of different spacing for the braille dots that are available. So if you do have parts that want to roll around, we can accommodate that. We also offer a medical quality grade platform that is also available for a couple $100 more. So keep that in mind. We do offer red, white, green, blue, and infrared lighting for these. You have to specify that ahead of time, and that cannot be changed. I know a lot of people ask, well, I have a red one, can I change it to a green? Well, technically, I guess you could, but you have to take the whole thing apart and it would probably void the warranty. These are all the controllers that we support. The T-Series, like I said, the T-Series can do 2 feeders. All these other ones can do up to 4 feeders. So if you want to bring 4 different components for assembly to a single robot, or if you want to have 2 feeders, one on either side, maybe this one's vibrating and shaking while this one's being picked from, you can do little tricks like that to try to increase your output. And this is the calibration screen. So literally, I've already taught the vision what a single part looks like. And now based on that, it's literally telling me to place 6 of these parts based on the part that you taught. It'll say, well, okay, now put 6 parts on the platform. And when you click run to run the calibration routine, it'll literally just start shaking the parts around and taking pictures with the vision. And if you watch it, you can see it'll kind of say, oh, I like that one. And it'll start to hone in on the final frequency. It's really slick. And that's really ball game is doing something like this. Part that you would create would be have their own, settings. So you can do up to 16 different parts with a single robot program. And you can specify, logical names to it or whatever you like. And the code for running the robot itself, I have it running out here. The program comes with this solution. So you would have to do little to no editing really of the main robot code that does the actual movements. Obviously, you'd have to teach the place point or any other special things that you want to turn on or off or things of that nature. You'll still have to put that in there. That's really about it. I know it seems pretty simple because it actually really is. Really, really interesting technology. And it's so easy to just switch from all kinds of different part types because literally, if you teach the vision properly on the setup here, you can easily. We do applications where you've got 2 different parts that you want fed at the same time. So we can feed 2 separate parts on the same feeder if you wish. We have done applications like that. I had an application where customer had 2 different parts that they wanted to assemble, and they would literally just pick one, place it in a fixture, pick the other one, assemble them, and then place the finished product down. So you can do interesting little tricks like that, assuming that the parts don't look extremely like one another. They got to be strikingly different from one another so that we can tell the difference between the 2 different part types, but that option is available as well. All right, I'm right at 30 minutes, Marv. Any questions?